All right, I think it's about time. Hi, everybody. Thanks for joining us today. My name is Simeon Vincent, and I'm a developer relations engineer working on Firefox add-ons. Today, I want to share a bit of information with you all about automated testing of web extensions. When I was originally working on this talk, I was planning to cover two main areas, unit testing and end-to-end testing, but unfortunately, due to unforeseen circumstances, I'm only going to be able to cover unit testing today. So I'm planning to follow up on this session in not too long with the other half. uh, so I don't know about you, but I have been consistently surprised with how large and complex the space of unit testing is. There are not just unit testing, of automated testing, of testing in general. I actually started my career uh, outside of college as uh, a quality assurance tester in the video game industry. So I have a more than average amount of experience living the testing lifestyle. And I've been consistently impressed with how large and complicated the space is. For example, there are a ton of different ways that you can break down the the systems around testing, that you can approach the process of testing. Both here we have like the functional and non-functional split. Functional being the operations and specific behaviors, the implementation details of your code, and non-functional being uh, uh, harder to define aspects, that it's not just the functionality that you're implementing, it's considerations like how usable is it for people with potentially different interaction modalities than you're typically used to preparing for and designing for, or what are the performance characteristics? Um, how well does this scale when you're dealing with a sudden burst of load, etc. There are so many different ways that you can break down the testing process, but today we're going to focus on two main areas. Well, we were going to. We're going to focus on one main area, uh, unit testing, and the other that we're going to tackle next time is end-to-end testing. These two concepts are related but notably different. Uh, End-to-end testing is also sometimes referred to as ETE. These are related concepts, but uh, they kind of exist on a spectrum where unit tests are small, individual, discrete pieces of an application, say a function that you're working with, or a particular system. End-to-end testing focuses on the entire system, the entire platform. Uh, I don't know if this is an existing term. So I might be coining it myself here, but I like to think of this as the functional test continuum, that we're kind of focusing on the two extremes here, on the smallest bits and the largest bits, and all of the different ways that you could potentially break that down. There are a variety of definitions and variety of approaches. We're going to leave those to the reader's discretion to explore and figure out kind of how best you want to approach these problems. Unit tests, according to Wikipedia, are a form of software testing by which isolated source code is tested to validate expected behavior, which is a fancy way of saying, like, you look at the individual pieces, the specific components or functions or uh, pieces of the application, and you validate that they are behaving as expected. And this a unit testing mindset puts you in position to verify at the lowest levels that things are behaving as expected, and as a result, hopefully, things compose well as they scale up. The other end of that spectrum is end-to-end testing, where testing is conducted on a complete software system. So rather than the individual like staples in the office tower here. We're looking at the entire thing. How well does the entire system behave and perform? Today, though, we're going to be focusing on unit tests, and in particular, unit tests for browser extensions. There are a wide variety of different unit test frameworks and tool sets and tool chains that you can use. Uh, and I personally don't have strong opinions on that front, so I'm just going to go with the masses here. This in the state of 20 or in the 2023 State of JavaScript survey, Jest was by far the highest used, according to the respondents of the survey, test framework that people were using. It also had, I think, the highest highest positive sentiment among respondents. Um, Other frameworks have held steady. Mocha here has been around 50% adoption for many years. Uh, and there are a variety of good choices. Ultimately, it's kind of individual preference. But for the sake of just getting something started and running with it, we're going to use Jest today. For this demo, I'm going to be using a sample from the WebExtension repository on GitHub. I believe it's mdn slash WebExtensions dash examples. Specifically, I'm using I don't even remember the name of it. I'm using a specific example from there. If you want to follow along and replicate this at home, um, feel free to clone the repository and do check out the notes.md file that is in the main branch, because that has the individual steps that you need to perform, as well as the link to the original source if you want to dig in and get more context. Once you've kind of taken a look at the notes and are ready to proceed, check out start. That is the start tag, and it is the kind of starting point for the set of steps that we're going to perform over the next few minutes. So when we're ready to proceed, we are going to check that out, and then that will put our repository into a state where we have an existing browser extension that was developed using Webpack, but it doesn't have any tests. So we're going to integrate Jest into that experience now. First thing we're going to do is run npm install with save dev for Jest. So we're adding Jest as a developer dependency, or as a development dependency to our project. Once we do that, we're going to open up the package.json file and then look for the scripts block. And we're going to introduce a new script into our project called test. And that's just going to run Jest. So now we're able to npm run test, and that will execute Jest and all of our tests that we have defined. So if we try to do that now, we'll end up with an error because, as it says, no tests found. We haven't implemented any tests yet. So that's our next step. We're going to open up source utils image store test.js, or we're going to create a new file. The extension already contains a number of files, and we're just going to start trying to build out some basic tests right now. So there are different strategies on how you can organize your projects and approach defining your tests. Some people prefer putting tests in their own dedicated folder. Some people prefer having them live alongside the files. For the sake of simplicity, our test file is going to, our test suite for this file is going to live right next to the original implementation. So when we open that up, we're going to import the library that we're testing, imagestore.js, and we're going to use a function, a global function that Jest provides to define a test. The first parameter is the name of the test, and then the function body is, the second parameter is a function that is the test to be executed. We can also see here another global object that Jest has exposed exposed called expect. Expect allows you to expect takes a value and then allows you to through a fluid API, like here we have .2b. It allows you to chain together and compose a statement about what you're expecting in this test. So this is an incredibly simple test. We're just saying that we expect the load store images function to be a function. That's a pretty low bar to start us off. And once we save that and then run npm test, we should get a passing test, something like this, where Jest tells us how long the function, how long the different tests took to execute, how many passed, how many succeeded, etc. There's also a little bit of a hint here at stuff we're not going to get into. Jest provides a ton of functionality that is incredibly cool and useful, and I strongly encourage you, if you start going down this path, to explore and experiment with it. Jest provides the ability to snapshot values and restore them across different tests that you're executing. Pretty cool, pretty useful. Now, as I mentioned, Jest exposes a ton of useful stuff. Not all of the functions that they expose can fit in this single screenshot. And I didn't want to make it any smaller because then it would be too hard to see. Well, we're just going to talk about a couple of select items here in order to start to give a flavor of what you can do when you're building your test suite. So one of the first things that I want to call out is that in addition to the test function, we also have a similar shaped function called describe. Describe allows you to essentially group different tests together in order to better organize the tests that you're executing and provide more structure to your approach to creating these tests. So for example, image store exposes a variety of different functions. And over time, we're going to expand the number of imports that we have here. So in order to help us keep our dependencies organized and to make the test results easier for us to parse later, we're going to have a top-level describe that scopes the set of tests to the individual function that we're testing. And in fact, describes can be nested themselves. So, for example, we could have a block inside this function for basic argument handling or parsing the return values and making sure that they're the correct shape that we're expecting. Another incredibly useful piece of functionality as you're getting started and starting to roll out your tests is the ability to focus the set of tests that are being executed by using this fluid API. For example, describe.only. That tells Jest that the only tests that it should be running are things that are explicitly marked with only. And by extension, test.skip says only things that have not been skipped should be run. This gives you the ability to, as you're iterating on your test definitions, as you're building out your test suite, it helps you focus on the things that matter most and trim out the noise. That way, you're just getting the most productive time that you can. I'm not sure why I had that slide twice. Oh, because there were so many other things that I wanted to cover, and I just ran out of time to come up with a bunch of definitions for them. So in addition to the high-level describe and test function, by the way, depending on how you're writing your tests, test is an alias, or it is an alias for test. So you can structure your test suite in a way that reads naturally as you're going through the content. For example, it's common to have like it should something as a statement, and then you kind of go through the sequence of tests and they read like a natural sentence. In addition to just the basic definitions of how to structure your code using describe and test, there are a number of other things that are incredibly useful. In terms of setting up an environment to make sure that your tests are behaving as expected, you typically want to minimize the amount of side effects, the amount of changes that one thing that happen outside of the scope of a function. And in order to kind of make sure that you're working with a clean environment every time, you can use these functions before all, after all, before each, and after each in order to say, like, here's, I'm going to need this object. I'm going to reuse it across a variety of tests, but it doesn't matter outside of this test suite. So after all of the tests in this test suite are executed, perform some cleanup. That way it doesn't interfere with other tests that are going to execute later. And similarly, before each and after each, allow you to prepare each individual test with a clean environment or a clean set of mocks. In addition to only and skip, some other useful utilities to help you focus on the right content as you're writing your tests are test.failing and test.todo. Failing allows you to say that this test that I'm currently working on is known to fail, and I don't want you to warn me about that. I expect it to fail. That's how it's designed. Or maybe as you're working on it, you're iterating on it, and it gets to the point where it stops failing. Now the test is ready and kind of finalized, and then you can remove failing, and then the test will continue to pass after that. Test.todo allows you to declare a piece of work that needs to be done in the future, and that to-do will show up in the test results as a reminder that you still have some more work to follow up on. And I should also highlight that all of these focus management things, the only, skip, failing, and I believe to do, all work for describe as well. I didn't have time to put together some concrete examples of this, but when you're performing or when you're structuring your tests, you have a variety of equality tool, or you have a variety of tools that are exposed on the expect object, the object returned by the expect function, that allow you to verify the contents or structure of the objects that you're interacting with, of the variables that you're interacting with. So you can, for example, say expect some value dot to be and then another value, and that will perform a strict equality check. Is A triple equals B? To equal is similar, but it uses object.is on primitives, which is actually better than a strict equality check because object.is also works for nan, not a number, and other exotic things that don't quite compare as you might expect them to. It also performs a deep equality check for objects. So if you have sub-properties on two different objects, you can use this to say, is this object, is it identically shaped to this other one that I'm comparing it against? To have property allows you to use chaining syntax, so like A.B.C, in order to specify a specific deep property that you want to check the value of. And to match object allows you to check if you have an object, like an object that contains A and that is an object that contains B, you can check if that has the same kind of shape as, same basic shape as the thing that is to match object against. So this can be used to say, make sure that the return object has these three properties because those are going to be relevant to the way my function is operating. Um, Jest also provides utilities for working with uh, promises. So you can chain expect a dot resolves dot to be y, and that once the a promise will resolve, it will compare that using a strict equality check against the value of y. There's so much more that you can do with this tool set. It's incredibly powerful and incredibly useful. I strongly encourage you to explore Jest or Mocha or any other test framework because speaking from personal experience, it greatly improves the quality of the products that you build. You know that you're getting the results that you want because you have an automated process in place that will always perform those checks and make sure that things are as you intended them to be. Um, I If you have any questions or would like to discuss anything that we've covered today, I encourage you to go over to the Mozilla Discourse server. I try to visit there a few times a week and talk about how to develop extensions and troubleshoot issues with developers. So if anything comes up, I'm happy to do what I can to help you all build a great extension. Thank you for joining me today, and I hope you have a wonderful day. Take care. Oh, I've signed off, except I think we're going to do some Q&A if there are any questions that have come in during this session.
Hey, Simeon, I've been monitoring the live stream platforms and we did not have any questions come in.
Okay. Well, if you do have questions, I encourage you to head over to the discourse and I will do my best to answer them. One final note, I am going to try to get the slides for this up in the next day or so. So check back on the description and the comments on wherever you're watching this, and you should have the slides available for you if you'd like to check out any of the links or references that I've included in the slides.